Okay, let's dive into this. The world of robotics is just exploding right now, moving faster than anyone can really keep up with. And if you're trying to jump in, that speed is, it's exciting, but it can also be super intimidating. So, in this explainer, we're going to build a kind of conceptual map, a better way to think about navigating this whole fascinating field. I bet this sounds familiar to a lot of you. This comes from robotics engineer Elliot from the channel Ubicoders. And it just perfectly captures that initial spark, right? That childhood dream of building your own R2D2, something smart that can move around and interact with the world. It's the why that gets so many of us hooked in the first place. And then you hit the wall. You've got the dream, but the actual path to get there is, well, it's foggy. On one side, you have these crazy dense academic papers that feel like they're written in another language. And on the other, you've got these little toy kits that are fun, sure, but they don't teach you the deep stuff. It's this huge, frustrating gap that just leaves you feeling completely lost.
So let's clear that fog. Instead of thinking you have to learn everything at once, we're going to focus on what really matters. We're talking about the three core pillars of robotics. This isn't about memorizing stuff. It's about building a better mental model.
And here is the absolute key, the big secret. It's not about becoming a master in just one thing like math or coding. The real magic, the real breakthroughs, they happen when you start to understand how all these different pieces connect to each other. So here they are, the three pillars. First, you've got math. Just think of it as the language we use to describe the world. Then there's code. That's how we write the actual instructions for the robot. And finally, the physical phenomenon. That's just the messy, unpredictable, real world the robot has to live in. The real engineering happens in what Elliot calls the bridging moments. When you connect a specific equation to a specific line of code to fix a real-world wobble in a drone you're building. That's the good stuff. And this analogy is just perfect. It totally illustrates the power of thinking this way. Once you have a real-world problem you're trying to crack, like stopping that drone from wobbling, all of a sudden, those abstract, boring math textbooks, they're not boring anymore. They become cookbooks, filled with recipes you can use right away. You know exactly what you're cooking for. Okay, let's zoom out for a second. Because this idea of connecting different fields, it's not just a personal learning tip. It actually reflects a massive paradigm shift that's happening across the entire robotics industry. The way we even think about building robots is fundamentally changing right now. You've basically got two camps. On the left, there's the old school approach, what we call classical robotics. This is all about building explicit mathematical models of the world. It takes a ton of human expertise to create these really brittle, step-by-step processes. But then on the right, you've got the new paradigm, robot learning. This is all about data. It uses huge data sets to let the robot create its own implicit models, leading to these much more robust end-to-end systems. So why is this big shift happening? Well, the classical way has some serious drawbacks. For one, those systems are really hard to scale up for new tasks. They totally struggle with modeling complex real-world stuff, like friction and contact. And because they're built in all these separate pieces, errors just stack up and the whole thing becomes super fragile. But the biggest thing? They just weren't built to learn from the massive amounts of data we have access to today. The learning-based approach just flips this whole thing on its head. Instead of that long, fragile chain of commands, you get a single, unified system. It learns to map what it sees, its perception, directly to what it does, its action. It is just a way more direct, adaptable, and honestly, powerful way to control a robot. Now, to make this a little less abstract, let's talk about a classic robotics problem that perfectly shows what we're talking about. It's one of the biggest hurdles you have to overcome to get a robot to move around on its own. The problem is called SLAM. It stands for simultaneous localization and mapping. And it's exactly what it sounds like. A robot has to do two huge things at the exact same time. Build a map of a room it's never seen before, and at the same time, figure out where it is on that map it's currently building. And that is the core of why this is so incredibly hard. It is the ultimate chicken and egg problem. To build a good map, you have to know exactly where you are when you take a measurement. But to know exactly where you are, you need a good map to look at. So how on earth do you solve for both at the same time? Now, while this sounds like some crazy academic puzzle, the truth is SLAM is already all around you. That robot vacuum cleaning your floor? It's using SLAM to not get lost. Self-driving cars use it constantly to know their exact position. Even the augmented reality filters on your phone, They're using a type of SLAM to make virtual things look like they're really in your room. Okay, so let's bring this all back together. Let's think about what this means for you, the person who wants to get into robotics. We've gone from a personal learning hurdle to a massive shift in the industry, and we've even looked at a real-world example. So what's the big takeaway here? This quote from a robot learning tutorial, it nails it perfectly. In the old world of classical robotics, the goal was to be a master of one, a deep, deep expert in just control theory or something. But in this new world of learning-based robotics, the real value is in being the person who can connect all the different pieces. So this is the thing I really want you to walk away with. Your goal isn't to be the world's #1 expert in linear algebra or in Python or in physics, all in their own little silos. The goal is to become the person who builds the bridges between them, the person who can see a physical problem, describe it with math, and then bring it to life with code. You are the bridge builder. Look, we started with that dream of building a robot, but also with that real frustration of not knowing where to even start. But now you have a map. You have a new way to think about learning and a new way to understand where the entire field of robotics is going. So the only question left is, what are you going to build?